All right, let's get started with our unit test for composite and inverse functions under the pre-calculus course. For the first question, we have function f graphed below is not an invertible function, which means they don't follow the relationship of one to one, which means that we don't have unique outputs for each unique input, that is one-to-one relation to which intervals could restrict the domain of f to make it an invertible function. So basically we should have a one-to-one relationship of the function, and we have multiple answers we can see. So if we restrict the domain to -5 up until to -2, let's see what we have. From -5 and -2, as we can see here, we do have a one-to-one relationship, so we'll choose that. For x is greater than equals to 3 but less than 3, less than 6, so from 3 to less than 6 we also have a one-to-one relationship, so we will choose that. And for x is greater than equals to 2 but less than equals to 5, as we can see from 2 to 5, here we from 2 up until 5, here we don't have a one-to-one relationship, because as we can see here, if we do from 2 to 5, so from 2 to 5, you see there is multiple values for x for the same y, so it's not a one-to-one relationship, and hence we don't select C. This is our final answer. For the next question, we have a composite function. We have to make g of f of x as an expression in terms of x, which means that we plug in f in place of g. So we plug this thing here. So in order to do so, first we create this, because we are inserting f in g. So for x squared, we have x minus 5. So we write x minus 5, and then that is whole square. So whole square, -12. And for x squared is the same thing. So I just copy this thing, and then we have a plus 4. So now you can see that g is everything the same, but we inserted the f on g, and this is the expression for g of f of x. Let's see. There we go. All right, so they're asking us to evaluate this thing. So first we do is plug in a -2 to f and see what do we get. So if we plug in -2 here, we get -2, positive 0, positive 2 is 0, and then we have to, whatever output we get from this function, we have to plug in here. So if we plug in 0 here, we get 4. So this is our answer. For the next question, f is a finite function whose domain is the letter a. To either following table is the output for each input in f's domain. Answer two questions about the function. Build a mapping diagram for f by dragging the endpoints of the segments in the graph below so that they pair each domain element with this coverage range element. Make sure to drag endpoints exactly. Okay, so exactly means we have to make sure we touch the green dot here. So let's initialize each thing, and then for a we have -36, so again -36. We have b pointing to 9. We have c pointing to -4. We have d pointing to 49, so d pointing to 49. We have e pointing to 25, and there we go. Is f invertible? Let's see. We have a one-to-one relationship, as we can see here, where each domain maps to exactly one range and vice versa. So f is indeed invertible in this case. For the next function, the following graph shows y equals to fx. Which of the following graph shows the graph, okay, inverse? So what happens exactly when we invert a function, the x-axis gets switched with the y-axis, so they interchange. So in order to do so, let's see, for 2, not 2, okay, for 3, for x equals to 3, we have a value of 4 for y. So if you draw the inverse function, this should be reversed. Okay, so here we have 3 4. So now we should have 4 3 in the graph, and let's see whether do we have that or not. 4 3, we don't have that, so this is wrong. And we have 4 3 here, and for here we don't have 40, and for here we don't have 43 as well, so which means B is our answer. F functions g and h are invertible functions over the domain x is greater than 0. G and h are given. Answer two questions about this function. Write a simplified expression for g of h of x in terms of x. So we have to plug in h to g. So for the the this thing, so we replace the x with entire thing of g, and then square that minus 8. This is what we have. Are these functions g and h inverses? Well, how do you know if they are inverses? Well, if we know the rule that if we have a function and that inverse function, and if we find the composite of that, the resulting answer should be x. So if you simplify this thing and get an answer for just x, then we can say for sure that g and h are inverses. So in order to verify that, we'll have to simplify that. So x squared plus 2 times x squared times 8 plus 64. 8 squared is 64, negative 8. And as we can see that this thing will not simplify to x, so which means that they are not inverses. And that's our answer. Robert is a stuntman planning to jump off a bicycle ramp and over an array of trucks. He modeled a few relationships, function as input, height of the ramp, r, and output, speed at the edge of the ramp, and for g we have input, speed at the edge of the ramp, and output, distance of the jump. For t, we have distance of the jump as an input and the number of trucks Robert can jump over um, t of x as an output. Which of the following represents the distance of Robert's jump as a function of the height of the ramp? Okay, so we need to find which of the following will represent the distance of Robert's jump. So we should have an output as the distance of the jump. No, yeah. So function representing distance of Robert's jump should have something in output. So what do we have? Here we have distance of jump. Yeah. So output must be d. So there we go. And for confirmation, um, as a function of the height. So what do we have here for SR? SR's input is the height. So yeah, this aligns with the requirement. That is the answer. The table below shows some inputs and outputs of function g and h. Evaluate. So h of g of 0. First, we plug in 0 to g. Yeah. Input 0 to g. So if we do that, we get 3. And then we then plug it again to h. So for 3, we have 5. That is the final answer. All right, function f graphed below is not an invertible function because it's not a one-to-one relation. They don't follow the one-to-one relationship. To which intervals could we restrict the domain of f to make it an invertible function? We have multiple answers. If we restrict it to -4, -8 to -4, what do we have? For -8 to -4, we do have a one-to-one function really. So that is correct. For -4 to 0, that is also correct. For -4 to 0, you have only one straight line. For 0 to 4, whoa, that is also correct because that is a one-to-one relationship. So all of them applies in this case. Okay, Andrea doubles as a professional pianist and dedicated mother. She modeled a few relationships. The expression A of S of K represents which of the following. So we have to check the function A's output. So A's output says it gives us the minutes of applause Andrea received after the concert. So the output of the entire thing should also match with that. So it should not be hours, it should be the minute of applause, but C also has the same thing. Now the input should align with the input for S because this is the inner function. So it is hours Andrea practice before a concert, and it's a function of B is a function of hours she sleeps. So and C is her baby wakes up at night. So S of K represents um, Oh, we have, this is not the output, this is the input. Hours, Andrea sleeps. So yeah, B is what aligns with our requirement, and that is the answer for the, and that is the end for our unit test.